Hey everybody, this is Gregory from Dapp University. So today I'm going to be talking about how to create transactions on the Ethereum blockchain with the Web3.js library. So Web3 is the main JavaScript library for interacting with the Ethereum blockchain, and I'm going to walk you through some step-by-step instructions on how you can use Web3 to create transactions on the Ethereum blockchain. And this video is part of a series, and it's not necessary that you watch the previous videos in order to follow along with this one. It's kind of designed to just pick up from scratch, but it might be helpful if you're new to the Web3 library to watch some of the previous videos in this series to gain more context about what Web3 is and how to use it. So check out those previous videos if you're interested. And also, I'm going to be releasing these videos on my website, so you can check that out at dappuniversity.com. And you can also follow me on Twitter for daily updates at Dapp University. So enough of that, let's jump in and start programming. So this tutorial today is kind of designed to go from beginner to slightly advanced. And what I'm going to do is talk you through what happens when an Ethereum transaction gets created and show you how to broadcast a transaction to the network manually with Web3.js. So in order to do this, we're going to need a few dependencies first. You want to make sure you have Node.js installed on your computer. You can check that out by going node-v. And we're going to need a few packages. The first is the Web3 package, npm install Web3. I've already got this, so just check that out to make sure that you do as well. And we also want to install a new package, which is called Ethereum JS-tx, and that would be like npm install this. All right, so I've got all these packages installed, so I'm not going to actually do that, but just make sure that you have them before proceeding. So one of the reasons I wanted to dig into Ethereum transactions and kind of talk about how you can do this with Web3 is because understanding how transactions work on the Ethereum blockchain is really important, kind of fundamental concept when you're developing decentralized applications, in smart contracts, or just interacting with the Ethereum blockchain, in JavaScript. Because anything that writes data to the Ethereum blockchain, triggers a transaction. It triggers a write. And those writes cost gas, and those writes actually change the state of the blockchain. And there's several different things that could do this. A simple sending ether from one account to another, will create a transaction on the blockchain. If I just wanted to send you, one ether, that would trigger a transaction, or that would write a transaction to the blockchain. And if I was going to call a function of a smart contract that actually wrote some data to the blockchain, that would also create a transaction. And if I was going to deploy a smart contract, that would also create a transaction. So understanding how these transactions work on a very fundamental level, and seeing everything that goes into broadcasting a transaction to the Ethereum network will give you a very good foundation for understanding some of these other high-level concepts that you might take for granted when you are developing decentralized applications. So let me kind of just show you an example of an easy way to do something like this. So first, I'm going to start up something called ganache, which you might be familiar with. This is a really kind of basic development blockchain locally. So the first thing I'm going to do is start out something called ganache, which is basically a local in-memory blockchain, kind of used for development purposes. And I'll show you. You might have seen this from my other tutorials. You can just download this. Just Google for ganache and download this if you'd like to, kind of follow along with this part. This part of the tutorial is not necessarily designed for you to follow along with, just as intended to demonstrate a concept. So, I've got this, blockchain running that I can connect to with Web3 on this local RPC instance right here. So I can copy this, and just like we saw in our previous tutorials, I can open the Node console, and I can, create a new Web3 object in order to talk to ganache. I'm sorry, Web3. I'll say require Web3. All right, and I can actually create a new connection to Ganache. 3 equals new web3. I'll paste in this URL. Actually, make this lowercase just in case. And now I can go back to Ganache and copy some of these addresses. I'll select this first address that's got 100 ether in it, and I'll just copy this, and I'll say const account1 equals this string. All right, and I'll also go back and say copy this address and say const account2 equals this string. And what I can do is basically say, like web3.eth.getBalance. I'll pass in the account1, and I can pass a callback function. And I'll just say console log result. All right, and we can see, this value that was returned. This is the balance of the account expressed in Wei, which is the smallest denomination of ether. This is not actually ether. This represents 100 ether. And now what we can do is like try to send some, ether from one account to another. And that would basically look like this. We would just say web3.eth send transaction. And we would just say, from account1, and we'd say to account2, say value, and this is where we pass in, the Wei value of the amount of ether we want to send. And we could say web3.utils, I believe it's 2 Wei, that's what we want. And we pass in, let's say 1 ether. All right, let's see what happens. Okay, so this returned a promise, which is an asynchronous function call, but I expect this is done by now. We're in a pretty fast environment with Web3. I could have, passed a callback function to this, but I just wanted to show you this in the console. Now let's see. We expect that this balance has gone down, so let's check that really fast. Web3.eth.getBalance. Actually, let's just go up. All right, let's see what happened to account 1. All right, we can see that the balance went down. Now let's actually log the balance of account 2, which we expected to go up. All right, it did. It went up by 1 ether. We can see that right here. Okay, so this is a really simple example of sending ether with Web3 by creating a transaction on the Ethereum blockchain, right? So I'm sending ether from this account 1 to account 2. And whenever I do that, I pay a gas cost to send, 1 ether from account 1 to account 2. It creates a transaction on the blockchain, and this second account's balance is increased by 1 ether, right? Okay, now, so that's a very simple example. Inside of a test environment with, something like test RPC or Ganache running, where you have access to all these accounts unlocked, and that's the key. All these accounts are unlocked when you're testing the blockchain locally like this with Web3. So like all these 10 accounts in Ganache come unlocked. So essentially what that means is in order for transactions to be broadcast on the network, you have to sign them with your account before sending them. And you can you can basically unlock your account so that all of your transactions are signed for you whenever you create them. And that's exactly what has happened with Ganache, which it removes some friction when you're developing, which is really nice. You don't have to sit here and type in a password or paste in a private key anytime you want to create a transaction without a front end client. And so that's kind of like why this happens with Ganache. Or if you were using something like Geth, you can unlock your account with Geth, with personal. If you're using Geth, you might have seen something like, personal the unlock account, which I believe is also in Web3, another personal namespace, Web3.personal. Let's see, Web3. Oh, it's under ETH, I believe. personal, right? And then we can say unlock. Yeah, unlock account. And that will essentially allow you to unlock an account, because whenever you use something like Geth, you have a way to manage accounts locally on the node. And I can get into details more with that, but essentially just know for now that, when you're developing, it's really easy to want to, do something like that, where you can just unlock your account without having to sign every transaction. So what about if you are using, an Ethereum node and you don't want to trust the node? You don't want the node to have access to any accounts. You don't want it to know about any private keys. You don't want it to know about any, key store files or anything like that. What if you want to keep all of your, account data local and, just use, sign all your transactions and all your messages and things like that yourself with your own private key locally? You would either have to, run your own you have to run your own node and, manage your own accounts with Geth like that, which can be very cumbersome. Or you can use Web3 and, sign the transactions yourself locally. And that's kind of what I'm going to show you today. And granted, that might be overkill for some, but it's kind of designed to show you, what's going on under the hood whenever you create a transaction, and kind of tell you why you could do something like this. So let's kind of dive into that a little further. I'm going to pull this over here, and I'm going to exit the console. I'm going to pull up Sublime text here so we can write some code. And what I'm going to do is show you how with Web3, you can basically create a transaction that's going to get broadcast to the network, sign it, and then actually send the transaction and broadcast it to the network. So the first thing we want to do inside of our app.js file here is require a couple things. We want to require this library that we installed in the dependencies section called var, we'll call it tx. This is require Ethereum js-tx. And you should install this with npm if you haven't already. And I'll say const web3 equals require web3. And then, just like we said earlier, const web3. And we'll say new web3. And also, in the previous videos, I got you started with using Infura. So check that out in the previous videos if you are unsure of how to use that. And make a note. Today, I'm going to be testing this out with the Ropsten test network. So, this is not the main Ethereum network. In the previous videos, we were reading smart contracts data from the main network, which is great because it kind of shows you how to use the main net. But today I'm going to be slinging some ether around, and I would rather, not potentially waste any money with gas costs and things like that. So I'm going to use the Ropsten test network in order to do this. And Ropsten is just a test network of, Ethereum, and you can read more about that. And yeah, so in order to get started, we need all these things. This is an Infura connection, and this is sort of the part of the points of the video. Like, Infura is hosting this remote node for us, and we don't want to give Infura access to our sensitive account data. We don't want to manage personal accounts on this Infura node, and so this is how we're going to actually sign and broadcast these transactions locally on our machine with Web3. So the next thing you're going to need are some accounts. And I am going to just paste in some accounts that I own. If you don't have any accounts, there's a couple easy ways to do this. You can either create one with Web3, or you can use something like MetaMask, which is pretty easy. You can go to MetaMask and go here and click on, I believe it's, hold on. Yeah, create account like this, and you want to export the private key as well, because we're going to need that. Or you can use Web3 and say log, we'll do web3.eth accounts create. and I'll show you that here. We did this in the last video. Save this. I'm going to run this script over here in my terminal with the node command, JS. This is my app.js file that I've created. All right. So this is going to show you, a newly created account and its private key. So if you're watching, do not use these values if you're going to connect to the main Ethereum network, because now everyone knows your private key, and that would be insecure. So don't do that. But that gives you an idea of how to create an account with Web3 if you want to follow along with this tutorial. So make sure you got a couple accounts created. So copy that private key that you created or that you exported from MetaMask or wherever, because we're going to need that in order to sign the transactions locally. And I'm going to, obscure these private keys from screen, because these are two accounts that I actually, I'm going to work with. So you could do that like this. I'm going to save mine to environment variables on my machine. And you can save environment variables like this. You can say, export, I'll say private key 1, and, paste in your private key here. All right. And I'm going to just say that. And, for example, I'm going to console log. I'm going to read this environment variable with node, which is what we're using to execute this JavaScript, with process.env.private key 1. All right, save that, and we'll say npm, node app.js. All right, your private key would go here. So that's how you would save one. So now I'm going to actually save my own private key off screen, and you're going to want to do this for private key 1 and private key 2. So I'm going to do that really fast, and I'll be right back. All right, now that you've got that private key, saved to your environment, I'm going to save these in my script like this. I'm going to say const private key 1, and we can say process.env.private key 1. All right, so we'll do this for private key 1 and private key 2. But there's a couple other things we need to do. We're going to use this, this library, Ethereum.js, transaction, in order to, sign the transaction that we're going to broadcast to the Ethereum network. And in order to do this, we must, convert this private key to a stream of binary data. And we do that with something called a buffer. So buffer is, globally available module in Node.js. And we convert it to binary like this, buffer.from. We just pass in the private key. All right, so we're going to do that for private key 1 and private key 2. So make sure you have saved, your second private key to your environment variable. And also, you don't have to do the environment variable stuff for this particular script if these are just, non-sensitive account data. You could just paste in a string here. That would be your private key. But, I don't want to show you my private keys in this tutorial, so I've saved them to my environment. All right, so what we want to do is let's just see that we've got everything set up correctly. This is kind of our initial boilerplate. I'm just going to console log, well, let's do this, web3.eth.getBalance. This is what we did a minute ago. Account, say 1, and then this be an error, balance, and pass this an arrow function. And now I'm going to console log balance. Web3, and I'll do it like this. Yeah, I could just log the balance, but let's actually convert it to Ether. So I'll say web3.utils from way, right? Because way is what we rebalances with natively. I'll say balance, and I'm going to convert this to Ether. All right. So this is going to be the balance of account 1, and I'll just go ahead and paste this. I'll say account 1 balance. And then I'll do this again. I'll say count 2 balance. All right. And remember, this is going to be actually on the Ropsten and Fura network. So I'll say node app.js, see what happens. All right. So So account 2 has a balance of 0.2 Ether, and account 1 has a balance of 3.85 Ether. Okay, so one thing I should mention is if you're following along with this tutorial and you want to use the Ropsten, Ethereum network, you're going to need some Ether. So the easiest way to do this is to use something called a faucet, which is just a smart contract that dispenses Ether. And you can basically use this link here. This is faucet.ropsten.be, port 3001. And you can make sure you have MetaMask installed. It'll detect your address, and you can just say this is the account that I'm using. We just logged this balance. You can select your account in MetaMask. Make sure you are connected to the Ropsten test network, and just say send me one test Ether, and it'll do it. So you're going to need some test Ether, at least the first account, in order to follow along with this tutorial. All right, so now we've logged these balances. We know everything's kind of got wired up. I'm going to clear this out. And what we want to do is basically build a transaction that we're going to send to the Ethereum blockchain with something with a function in Web3 called send a signed transaction. So what we're going to do is basically we're going to build the transaction. We're going to basically sign the transaction, and we're going to broadcast the transaction. All right. So I'll start down here and say this is how you're going to broadcast a signed transaction with Web3. So we'll say web3.eth send signed transaction. This is a function that's going to send the actual transaction, but it's going to expect a signed transaction, and this will accept a raw transaction and a callback function because it's an asynchronous function. So we'll say error, and then the tx hash. That's what it's going to return. It's actually going to return the identifier of the transaction that gets created. So when you're creating transactions in the Ethereum blockchain, it's going to return this hash that identifies the transaction, and that's going to be represented inside the block. And we can examine this transaction on etherscan, which I'll show you in a little bit. And I'm going to pass this function. So I'm just going to console log the transaction hash. We'll say tx hash, and when we get this transaction hash, we will go inspect this on etherscan. All right. So before that, we want to. So that's going to be broadcasting the transaction. All right, that's how we do that. Now we're going to sign the transaction in a minute. Let's actually build it. Kind of show you what the transaction object is going to look like. We'll say const tx object. It's going to equal this JavaScript object. It's going to require a few fields here. It's going to require who we're sending it to. It's going to be an account. We'll say account 2, right? We want to send a transaction from account 1 to account 2. We want the value, and we'll fill that out in a second. We want a couple other fields. We want the gas limit, and we want the gas price. All right. So these things right here, like anytime you create a transaction on the Ethereum blockchain, you have to pay gas. That's the cost of running the network. Essentially, the gas cost is going to be the reward that's sent to the miner who mines the transaction and writes it to the blockchain. And the total gas consumed is not like represented by a one-to-one relationship with Ether, right? It's not like 1 Ether is 1 gas. Gas is just expressed in units. That's calculated by the gas price. And the amount of gas used. So we need to specify gas price and a gas limit. So the gas limit is going to be a safeguard that says, if something bad happens, don't spend any more than this amount of gas. It's going to be a safeguard that allows us not to drain our account. And the gas price is going to be the cost of each unit of gas when we send the transaction. So, and then the last thing that we actually need, I'll fill these out in a second. The last thing that we need is something called a nonce. And nonce is basically this account's transaction count. It's essentially what it is. So it's a safeguard. It's a number. It's a safeguard that helps prevent the double spend problem. So basically, like this, if I've created 0 transactions yet, like if I have a brand new account, if you created a brand new account, your nonce value is going to be 0. And after you create your first transaction, it'll be 1. And after the second one, it'll be 2. And essentially, when we're broadcasting a transaction to the network, there's potentially this kind of race condition where if you're sending a bunch of transactions, we need to know how many there are in order to prevent double spend. And that's what this value is. So we'll fill these out here in a second. Let's start with the nonce. In order to do that, I have to get the actual transaction count of this particular account. I'll do that like this. Web3.eth.get transaction count from account 1, because that's who we're sending it from. 1, all right. And we'll say this will accept a callback function, which will be an error or a transaction count, all right. And now we have the actual transaction count that we can use to fill out this nonce value. But we really want to execute all this stuff after we have this transaction count because we need it in order to fill out this nonce. So I'm going to copy all this and put it inside this callback function. And do like this. All right. Now we have a new kind of workspace. So after we get the transaction count, we can fill out this nonce like this. Say, TX count. But here's something that's important to know. All these values when we're, sending this transaction, when we're filling it out, we're building this transaction object, need to be in hexadecimal. And we can convert the transaction count, which here is just going to be an integer. Like if you have a new account, it's going to be 0 or 1 or 2. And we can convert this number to hexadecimal like this. We have 3.utils to hex. All right, pretty easy. And the account's already in hexadecimal. We see that here. And now we want to actually fill out, the amount of ether that we want to send from account 1 to account 2. Now we can see our account 1 had 3 ether, and probably is going to have another ether because I just requested one from the faucet a second ago. So if I console log this value, it would go up. But we can fill the value like this. We say web3, convert to hexadecimal, web3.utils to hex, right? We're going to fill in the value here. And we need to convert the way value. We want to convert the amount of ether we want to send to way because, all of the value field, everything in the value field when you're sending a transaction has to be in way because that's the smallest unit that the actual Ethereum network deals with. So web3.utils to way, and we'll send 1 ether, 1 ether. All right. And now we want to calculate the gas limit. I'm going to say web3.utils to hex. Oops. Yeah, to hex. I'll say 2,100 units of gas. That's kind of typical for creating a transaction. And I'm going to say web3 utils to hex for calculating the gas price as web3.utils to way. And I'm going to say 10 GWay, and this is a larger denomination of Way. You can check that out in the previous videos where I show you kind of how convert Ether to Way and Gwei and all that kind of stuff. So this is a pretty this is our complete transaction object that we're going to build in order to sign this transaction and then broadcast it. All right, so take a deep breath if some of this is a little overwhelming. If this is a lot of information, don't worry. Like I said, some of this may even be a little overkill for this particular case, but it's designed to show you how these transactions work and how to actually create a transaction with Web3. So you might notice that there's no from field in this transaction. That's because it's going to be unnecessary when we sign the transaction. We're going to sign this transaction with our private key, and when we sign it with our private key, it's already going to know who sent the transaction because the public key is just a public representation of our private key, and whenever we sign it with a private key, it's going to know who sent the transaction. So the from field is going to be irrelevant. So we can sign the transaction like this. We'll just say transaction equal to. We're going to create a new transaction object with this library that we imported. It's Ethereum.js TX. And we'll say we're going to pass in this transaction object we just created. All right, and now we're going to sign it like this, TX sign, and we're going to pass in the private key. All right, this is the private key of account 1 because that's who we want to, send Ether with. We want to send Ether from this account to this account. In order to do that, we must sign the transaction with this private key. And this private key, is a stream of binary data from our private key string. All right. Now we signed the transaction. We've built this object. We've signed it. Now we basically must, serialize it and convert it into a hex string that we can pass into, we can convert it to a raw transaction that's going to get passed into this send sign transaction function call. So we do that like this: const serialized transaction equals tx serialize, and we'll say const we'll say raw transaction. We got to basically just prepend a string with 0x and convert the serialized transaction to a string. And we wanted to convert it to hexadecimal. Just like that. All right, so that's how we build this transaction. All right, so let's actually kind of log some of this stuff before we send it out, so I can kind of show you. Let's just console log the transaction object. Now, I probably should have done this earlier to keep your attention. So my apologies, but I'll go ahead and do it now. Let's say, this will also check to make sure I didn't make any mistakes. Node, app.js. All right, so you can see the calculated values here from this transaction object. This is the nonce value in hexadecimal. This is the account that we're sending it to. This is the amount of Ether expressed in Way in hexadecimal. This is the gas limit in hex, and this is the gas price in hex. All right, so kill that. And let's actually see the transaction object here. Well, actually, I don't want to do that because I don't want to show you the private key. Well, I don't really care that much. Well, actually, yeah, I'm going to save it for now. All right, so you're welcome to console log all these values yourself and kind of step through this if you want to. But I'm going to just go ahead and try to see if this thing works. All right, before we run this, I realized I made a mistake. We need to actually specify how we want to convert these private keys for the buffer object. So you'll want to pass in hex to specify the format. All right. So let's try to run this and see if it works. We'll say node app.js. All right. And there we go. We have a transaction hash which is the value that we logged here, which means that this transaction was successfully broadcasted to the Ropsten test network. So let's see if we can actually see this transaction on etherscan, and let's see if it actually worked. So I'll copy this. I'll pull up etherscan here. So etherscan is a blockchain explorer, and you can visit the Ropsten subdomain of etherscan to get the Ropsten version. Don't actually visit the main Ethereum network if you're using the test network. So I'm going to paste in this transaction hash that we got from our console here, and click go. And we can see that the transaction was successful. We can see that we actually sent 1 ether. We can see the gas limit that we specified in the transaction. We can see that the actual gas used was 2100. And we can see the account that we sent it from, 7E3 in our file, 7E3. And it was sent to 7CD, right? 7CD right here. And yeah, we can see that it actually worked. So that's a great success, guys. So now let's actually let's comment some of this out, and let's just say we can log the values of the accounts, just check to see locally that we can still read this data. Say web3.eth.get balance, pass in account 1, and say error balance. And we'll say console log web3.utils from way and the balance and then ether. All right, and we'll do this for account 2 as well. Actually, let's say account 1, and we'll do it for account 2 as well. That should be account. All right, node app.js. All right, we can see the balances have changed. We sent 1 ether to this account, which previously had 0.1, and it increased by 1. All right, guys, so that's all I got for today. That kind of shows you, how you can, create a transaction manually with Web3.js. Shows you how to create this transaction object, how to sign the transaction, and actually how to broadcast the transaction to the network yourself without having to use a remote node that you trust. You don't have to trust a node to manage your accounts, and you don't have to download Geth and run your own Ethereum client locally either. You can do everything here locally on your machine in a very kind of light way. Now, granted, this is a little complex, but that gives you an idea of how you could do that, and it also gives you insight into how transactions are actually built when you are using and developing for the Ethereum blockchain. So be sure to subscribe to the channel and check out the next video in the playlist whenever I release the next video in this series. And until then, thanks for watching Dapp University.